Yeah, go ahead and start running around in circles. Let me go ahead and write some things on the board for y'all. I'm sorry, I can't hear you. I'm fixing to write some stuff on the board.
Okay.
I can't hear you right now.
All right.
Okay.
He likes those.
Yeah.
Winner's the final.
Yeah. Okay, come on, whiteboard. Yeah. Are you registered yet? You registered on My Last Plus? You got to get that done first.
What is the
You need
website again?
You need the website. Yeah, there you go.
I keep scratching off the little thing, and it doesn't say winner. It's just a bunch of letters and numbers.
I know.
Like, what do I do with this? And I spent like $4,000 buying those things and scratching them off.
Those things are $100 a piece.
Can't catch a break, man.
Homework. No, I don't write it down. Homework
I'm listening.
will terminate at midnight on July 25th. 2. Last test will start July 25th and terminate on, when's the final, for 26th? Well, we're going to cut it off on the 27th. Midnight. That's some kind of religious organization. All right, on the 25th, 26th, 27th. There's a reason I do that. Okay? Yeah, I hate y'all. 3. Any. Hey, be quiet. Any homework or test that has not been completed will receive zeros. Y'all understand that, right?
There's no number in front of the zero.
Yeah, there's no number.
Not like a one.
Mm-hmm. Therefore, grade will decrease if you haven't completed all assignments. I know. Everybody should get a trophy. All right? All the homework assignments, and there should be 3 unit tests. Unit 1, Unit 2, and then this last one, which will be Unit 3. So you should have 3 tests, and you should have all the homework. If you've done everything, you don't have anything to worry about. I always do something at the end of the semester. Look for it. And don't go stupid on me. Okay? Now let me explain that. Let's say that I've just returned your test. Let's say I gave you a hard copy test, and I give you your test back, and everybody starts noticing I put 10 points on everybody's test. Are you going to raise your hand and say, you gave me an extra 10 points, you need to take it off? No, you're not. So if you see something, you're on homework, or you're on test and you see something and you do this, should you get on the email and say, Hubert, I noticed this and I was wondering? No. Or should you take advantage of it?
Take advantage of it.
Thank you. Oh, yeah, I was wondering. I'm a little bit confused. Good God Almighty. Okay. Grades are to be turned in yesterday, so I will not be able to extend anything. Now, what is yesterday in the, you can answer this, what does yesterday in quotation marks mean? That they want the grades turned in when? 10 minutes after the final, yes. Maybe 10 seconds after the final exam. All right? So what I'm trying to tell you is after the 27th, I cannot extend anything. Okay? Because they want the grade. They say that grade turn in August the 2nd. Yeah. That's what they put on paper. Okay? What you don't see on paper is the person calling you every 5 minutes saying, your grades have not been turned in. When are you going to turn them in? Your grades have not been turned in. When are you going to get an email? When are you going to turn in your grades? You're about the only, there's only 5 people that have not turned in your grades, and you're one of them. Okay? And if you used August the 2nd, they jump all over you and say, well, you can't wait till the last minute to turn in your grades. All right? So I'm just telling you, they put August the 2nd, or whatever they put, grade turn in. But they really mean July 30th or July 31st. That's what they really want. Okay? Or any of this other final exam is, I don't know how to spell this word. Cumulative. That means that the final covers all of my tests given. Now that's what I'm trying to tell you. If you want to study for the test, study your Unit 1, Unit 2, and Unit 3 test. Go to Gradebook, hit Review, and hit Print. Okay? And they'll print out, and then you can review them. 7 will be 2 forms of the final exam. Here's where I always get the question, well, how are you going to grade that, Hubert? Well, let's see. All through the semester, I've taken the highest of 3 grades, highest of 4 grades. So, of course, on the final exam, I'm going to do totally opposite, right?
I knew it.
Yep. I better put this down.
You're going to take the lowest, right?
I'm going to take the lowest, yes. I will take the highest grade. I have to put that because somebody will go, are you going to average those 2 grades? Do I respond? No. 8. The final is online. Although I have to give y'all an in-class final exam. So y'all need to show up for the in-class final exam. What day is it?
Sunday.
Let's look. Do I put it past somebody showing up during my final exam to see if I'm giving them one? No. I don't put it past them at all. Do they show up at the teachers that have a 17% retention rate? They show up in their classes? No. Irritates me to death.
Then I can change your password all the time, though. I get so tired of that.
I've been here 20 years. This is number 20. I just put a number on the end of it.
You just get that.
Yeah. And if you don't change it, oh my God, it's like an act of Congress to get it fixed.
So I want to change it, and the little screen where it has your username and like your T number and your birthday is not right. It locked me out.
Oh
I was
gosh.
like,
All right, here y'all is.
You need to change that. It's not right. I was like, yeah, you do.
Your in-class final is Wednesday, 8 to 10. Wednesday, 8 to 10.
No, that's for 103.
Oh, is that 103?
We're right
Sorry.
under there.
I mean, it'll work. It's the same test.
Show up anytime. I really don't care.
I don't think the test is any different.
Let's take this out.
Yeah, I'll take it.
There they are. I don't care. Show up anytime you want to. I don't really care. Just show up those 2 times for your in-class final exam.
I'll show up both of them first, so yeah.
Okay, make sure you show up. Because if you don't, you won't pass the course. Okay, now I can't. What? Well, just trust me, okay?
Yeah,
Be here.
And my Spanish is rusty now. So.
After the test, I will tell you, after you see the test, you'll understand why I can't sing.
I have a feeling it's gonna be good.
Don't say anything. Can't say anything because it's the in-class final exam.
It is going to be a cumulative representation of the objectives that we have done in probability.
No, it's not going to do that.
What branch did you?
There you go. And it's going to be part of your final exam grade, so you have to take it. Because we have to have an in-class final exam. What? Be here? Because you got to be here for a test. You got to be here for the final exam. I'm sorry. Because if I let one person not take it, then the whole wall will fall down. I have to be. This is not me. I am not doing this. You can put this on your evaluation that is stupid.
So either
Wednesday or Thursday.
Oh, you're serious. Dang it. I thought you were just saying that.
No, I have to. This is no joke.
So just normal class time work.
No, we don't have classes that week.
Well, but Thursday.
The final is online, although I have to give y'all an in-class final exam. 9. Let's see, what other stupid questions are there? Oh. Where do you find your final grade?
In the box.
Google it.
well, we just call you.
Yeah, call me.
Yeah.
I'll answer.
You'll find
You'll start doing it Friday night.
Now make sure you check it after checked grade after you have completed all assignments.
Okay.
Okay, please don't check it before you take your final exam. I had one student do that before, and they had an A, so they didn't take the final exam.
What?
Oh, yeah. I've had people like that.
We're going every day.
These are the people that can't tell you who won the Civil War or July 4th is Independence Day from the South.
Oh,
You know, those people that should not procreate.
if they're going to come on Wednesday morning, what are you going to do?
Same classroom. Oh gosh. We'll be in this classroom probably. I don't know. I'll figure that out when we find out how many people we have that morning. Try not to come on, unless it's totally emergency, come on,
Normal class day.
what day is, no.
Ours is Thursday.
7 to 12.
Yeah, come, yeah.
If I can't see it, I don't understand.
Can't see it? I can't see it. Everybody say I can't see it.
I don't see it. It's below it.
Just
right
wait
there.
2 or 3 seconds, okay?
Say it louder in the back.
Let me change the. Hold on, I'm gonna change the font.
If you change it too much, it's going to tear my nose up. So please be careful.
There. Y'all come at 12 o'clock unless absolutely, positively emergency, because that room only holds like 10 people. Okay? So be here at 12. And make sure you complain about having to take the final exam in Hubert's class. It was awful. It was hard. It was terrible. No, you can't come at 1:30. Come anytime between 12 and 2. The in-class final exam shouldn't take more than 15 seconds.
Are we gonna have to explain what a social sort?
Yeah. No sniping. You have to be here. Sorry. Like I said, if it ain't broke, fix it. I have been doing MyLab Plus and Course Compass since 1996. I haven't given an in-class test since 1996, and I'm not beginning to start.
It's my fault.
Well, who's going to grade it? Y'all are.
I don't even look at it. It's gonna be one.
Okay? All right. Does anybody have any questions about any of this? Okay? Now, right in this, the only ones that have an in-class test, I'm going to put this. Because I'm gonna have 30 people emailing me. No, 60. The in-class final exam is only for math 120, 12, and math 103, Polycom. The Math 120 online does not have an in-class test. See, that's another thing. You know, online, I'm surprised that they don't make us give them all in-class tests.
But I don't live as like that. You better do it.
Okay? Any other questions on the last week? And remember, if you go on the test, or you want to take a test, or you go on to do your homework and you see something funny, you're supposed to sit there and stare at your computer for an hour or two and email me and ask me stupid questions. Or you're supposed to take advantage of the situation. Yeah. Will you get a response? No.
There's money involved in this.
Donations are accepted.
I have a question that I don't know how to ask.
What?
We still have a test for the final.
Yeah.
Okay, so
The final exam is good, and they'll both end. Okay, I didn't put that. Final exam. Hold on, let me go down here. Final is all online. It will terminate on the same day that this one will. Terminates on the 27th.
I think the in-class should be about
The in-class will probably take you all 2 hours at least. Yeah, this is going to be lethal. That way you can tell my boss that I gave you an in-class final. It was terrible. Just show up. Just show up. Trust me. Trust me. Okay? All right, who else got questions?
Maybe have snacks for us?
What'd she say? What'd she say?
That's nice.
Who?
That's a good question.
Oh, you want me to bring snacks?
Yes.
I'll bring snacks.
Thank
I like it.
you.
I eat it. I'll actually eat it. Just say thank you.
You know what? They'll be free, and you will eat them. And if you don't eat them, you say no thank you.
I will say thank you.
Okay?
Thank you.
You're not going to be one of these people that I don't like those donuts. Those donuts are from so and so, so and so. Get out.
That would be an option.
Bought biscuits that time for everybody. Bought 25 biscuits, 30 biscuits, 5 of this, 5 of that, 5 of this. Where'd you get them? You want a damn biscuit or not? Okay. All right, now let's get on back to the program. All right, everybody got that? Look at it.
Yes.
You got it? All right. Now let's move on to our PowerPoint. I think it's this one. No. There we go. All right, now what I'm going to do is I'm going to go through this PowerPoint today, and then we're going to work on nothing but problems Monday. Okay?
Monday.
Whatever. Whatever.
You know how all that guy, we're doing that just yesterday.
Yep. First of all, uniform distribution. Write it down. This is an example of uniform distribution. Now, if I give you 10 questions in chapter 7, one of them is going to be uniform distribution. All right? The rest is going to be normal distribution. The area under the normal distribution and the uniform distribution is both 1. Okay? So if you have an area, it's going to be 1.000. Hold on just a second. Let me get my handy dandy whiteboard fixed. There we go. So the area under the curve, or the area under this rectangle, is 1.0000. I usually carry it to 4 digits because 4 digits is area. Now I might have told y'all this before. Area is the same as what? Percent and what? Probability. Remember me telling y'all that?
Yes.
I think 2 digits is a z-score. Now you don't have to worry about the z-score right now, but just remember this because a lot of people wonder why I write the area in 4 digits. That way I keep the two numbers different when I'm teaching. Now, the only uniform distribution that we know of, well, one of the best ones that we know of, is what? Why? Because you can't do what? You can't change it. It's the only thing, really, that we have no control over. Okay? Even though some people do try to control
What was
it.
the common random variable last time?
Huh?
What was the question that
I said,
The most,
what is the most uniform thing that we know of? Uniform distribution. See this line right here? What do you notice about this line right here?
It's straight.
Why? That means no what? No variance, no variation. No variation means it's uniform. The only thing, one of the best known things that we know that has no variance is time. Because we cannot what? Control it. We can't change it. Like I said, even though some women try to change it. Most of the women. No.
plastics.
Go to a dance recital and look at the moms, or a cheerleading recital and look at the moms. trying to fit in their daughter's clothes. It's not very pretty. Okay, guys don't do that. Guys just hang out at the mall when they're 50 years old. You know, they're just pretty sad. Those are the two equal sad things. But anyway, time we cannot control it. So therefore the variation is not there and it's uniform. Now, how do you figure time? Length and width. Since this is a rectangle, this is your length, this is your width, or this is your length and this is your width, it doesn't matter. And that's going to be dependent upon this area of 1. Let's do an example. All right, here's an example. X less than blah, blah. Okay, I thought they were going to give us a... Okay, they didn't. I thought that was an example. Come on. Okay. Okay, here we go. The probability of choosing a time that is between 15 and 30 minutes after the hour is the area in the uniform blah, blah, blah right here. What is that probability? What is that area right there? Well, first of all, you got to find the height. Okay? How do you find the height? Well, you use your area. Okay. Here we go. So here we go. Area equals length times width. 1 is equal to, our length is 60, and our width, we don't know. We don't know this. We don't know it. Okay? Divide by W, divide by 60. Divide by 60. And W is equal to 1 over what? 60, which is number right there. So when you're dealing with uniform distribution, the first thing you do is solve for W. And that's how you do it. Now most of the time, since there's 60 minutes in 60 seconds in a minute, and 60 minutes in an hour, most of the time you're going to have 60 on the bottom, unless they change it to your class meets from 2:30 to 2:30 to 3 o'clock. Okay, then it's 30. Or you wait in a bank teller line for 15 minutes. Well, then it'll be 15. Okay, if they come off of the 60, they come off the hour. You use whatever they give you. 15 minutes, 20 minutes, 30 minutes, 60 minutes. Okay? You find the width, which is going to be a portion of that time. Okay? And then they ask you, what is the area between 15 and 30? Well, you've got the height now. The height right here is 1 over 60. What's the length? 15. So now you say 15 over 60. So the blue area, the area in blue is equal to 1/60 times 15, length times width, which is 15 over 60, which is what, 4? No, 1/4, sorry. Is it 1/4? What's 4 times 15? 1/4, which is 0.25. So there's a 25% chance that the time that they're asking for is going to fall between 15 and 30 minutes, or whatever the question is. That's how you find uniform distribution. It's real simple, but it's not used a lot because the only question you can ask about is time. Unless you have something else that is non-controllable. Okay? And what I mean non-controllable is you can speed it up, you can slow it down, you can turn it up, you can turn it down, you can turn it off, you can turn it on. Heat. What can you do to heat? Well, is it in an oven? You can turn it up, you can turn it down, you can turn it off, you can turn it on. Yes, sir. Hmm?
It's not an X, it's a time sign.
This right here, you have to have the height. You have to have that. If I gave you the same type, and I gave you from 0 to 20 minutes, then this would be 1/20. If I gave you 50 minutes, it'd be 1/50. If I gave you 45 minutes, it'd be 1/45. So you might want to be careful. I mean, if you want to just put it over the time, you can do that. But they may change the question to where you have to subtract. So you've got to be careful with that, okay? You have to have the height. Okay? Now again, you're only talking about 1 out of 10 questions. Now, here's the 9 questions. Normal curve. Everything else is going to be based on the normal curve. And since the first homework, I've been showing y'all how to draw the normal curve with the 2 most important things, the mean and the what? The reason I've been showing you that is because when you get to chapter 7, it'll come as second nature for you to draw it. Okay? Now, this is where I tell people again, it would behoove you to take a sheet of paper or go to the Google. I know this is a lot of work. Click on the Google search bar, look up normal distribution with z-scores, copy and paste onto a word processor, maybe 6. Print that out and run like 10 copies. So you'll have like 60 of these drawings. You'll see the drawing I'm talking about in just a minute.
No, you should do that. Email it to us.
I emailed it to y'all. I guarantee you there's somebody in here that didn't use it.
You said you also.
Because you have to actually hit the print button, and you have to get up and pull it off the print.
Yeah, it was like on the other side of the room. I ain't looking at it. Who's got time?
Yeah, I know. All right. Here they tell you to make sure you put the mean in the middle, and then add what on the side, and subtract what on the side. Standard deviation. I've shown you how to do that. That way I wouldn't have to show you here. Here they comparing it to a low standard deviation and a high standard deviation. High standard deviation is going to spread it out. A low standard deviation is going to make it taller. That's not a big deal here. Okay? It is symmetric about the mean. The mean's in the middle. The curve has a single peak, highest. This is really not a big deal. Here, this is important. The area under the curve is what? 1, just like the other. So that's important. And remember the empirical rule. Up to half, it's what? 50%. On the right side is 50%. On the left side is 50%. Remember the empirical rule. As x increases without bound, gets larger and larger, the graph approaches but never reaches the horizontal axis. As x decreases without bound, gets more and more negative. Oh, I thought this was an example. Well, I mean a problem, the question. This is talking about the normal distribution, okay? Again, that's not important. Number 4 is the most important. Look there. The empirical rule. Y'all already know it. Mm-hmm. There it is.
Recognize that.
Ah,
I've never seen
The empirical rule.
When
All right, so make sure that if you didn't copy it down in previous sections, that you copy it down here.
it. And this one got right.
I didn't go over it.
last month, you missed that one.
You got to blame it on me. You got to make sure you don't give me anything. Okay, I didn't think it.
You said.
Mm-hmm. Says the data on the next slide represents the heights and random people of 52-year-old males.
Yeah, they said that was.
Of a sample of 50.
2-year-olds.
Two-year-old man.
Little ones. Did they make that more confusing? They should have put the 50 in parentheses.
Yeah.
That would have helped.
Draw a histogram of the data using a lower class limit, blah, 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 blah. Do you think the variable height of 2-year-old males is normally distributed? Oops. There they are. Now, I'm not going to ask you to write those down, but here's the histogram. Is it a normal distribution?
Yes.
Yes. And you see it goes up and then it goes down. So yes, it is. We have a normal density draw curve. How does the area of rectangles corresponding to the height between blah, blah, blah relate to the height under the curve? Between 34 and 35.5. 34.5 and 35.5. Well, you know that this is half right here. That's half. So you know this is like 50%. Okay? But you also know that this is in the middle right here. So the area, I don't know how you would do this because that would be 50%. And then you know that each one of these is equal to, well, you're going to have to use the empirical rule. You're just going to have to use, you could actually do it like this. You would take your handy dandy.
It's telling you something.
What?
It's telling you something. It's giving you a clue.
What is it?
This is like a skateboard.
Okay. We know this is 34%. I mean, this is 50% over here. And we know that this right here, this one plus this one is 34 plus what? What is this one? I always forget. Is it 11 or 12 point? 13.5. So 13.5 in this one, 13.5 and 34 is 47.5. So 47.5 is going to fall right, I'm going to draw it right here. 47.5 is right here. So now what they're looking for 34.5 and 35.5. They're looking for this green area here. I would say it's probably about 10 to 15%. So you're probably talking about 0.15, because you could say this is 50. You could say that's 50. No sneezing, please. Let's see, that would be 47. I'm looking at it. I'm looking at this is 34%. If this is 34% right here, then this looks like this is about half. That and that right there could equal this. So I'm thinking maybe probably less than that. Probably this is 10%. So I'd say this is around 24%. Just eyeballing. I would say around 24%. Maybe a little bit more. But what they're getting you to do is they're getting you to look at the empirical rule and seeing if you can figure out by eyesight how much it is. I don't know. That's not what I'm going to test you on. Okay. Now there's a way we can do it by using the z-scores. Okay, look at that one. Write this one down. It says the weights of giraffes are approximately normally distributed with a mean of 2,200 pounds and a standard deviation of 200 pounds. Draw a normal curve using these numbers. What goes in the middle? 2,200. $2,400, 2,600, 2,000, 1,800. Draw a normal curve. Shade the area under the normal curve to the left of 2,100. Well, if this is 2,000 and this is 2,200, what's in the middle?
2,100.
Suppose that the area under the normal curve to the left of x is 2,100 pounds is 0.3085. Provide two interpretations of this result. All right, so if this is 31%, if this shaded area is 31%, what's this say? 69%. Why? Where'd I get that?
Compliment.
What? How dare you remember stuff that I've taught you?
What?
You didn't teach me that.
Okay. Compliment.
They googled it real quick.
You can say 1 or you can say 100. It doesn't matter. You can say 0.31 and it would be 0.69. What else can you say? That people that, whatever this is, okay, that giraffes that are below 2,100 pounds are in the 31st percentile. You can say that. You can also say that half the population is above what? 2,200 pounds. There's all kinds of things you can look at with this.
It really didn't tell us what the 2,100 pounds is. They just threw the number out there.
Yeah, they just didn't
It's like, really?
Well, what they wanted you to do is they didn't want you to go, well, there's 2,000 and there's 2,200. Where's 2,100? They didn't want you to do that.
It's okay.
Yeah, pretty much. If you're still trying to find out where 2,100 is, then that's the person they're targeting.
It's not relevant.
Okay. Next.
Here we go.
See?
This is the answer.
There it is.
There it is.
That's the only way.
Now, here's where we get into the test questions. You already got one test question, and that is
Uniform distribution.
thank you.
There you go.
Okay? You ever have one of those days you can't talk?
I live in those days.
Yep. Now we're going to talk about z-scores. Write that down. Z is equal to x minus mu over standard deviation.
Once I put my nose, I was ready.
Oh no, it's medicine. Yeah. Why don't you just say date? Well, Mama says everybody's on date. Somebody be walking down the road. I said, Mama, what are they? They probably on dope.
It's probably right. Keep pegging. As soon as she says that, they say, oh, I miss some dope.
X minus mu over standard deviation. Now I also want you to write down, well, you don't have to write that down yet. Well, go ahead. Let's write down X, and I think I've showed you this. X is equal to Oz plus what? Mu. Write that down also. I think I showed y'all that earlier. Well, that's why I do it that way, because if I did Z times standard deviation plus X bar, you wouldn't remember it. Yeah. Now what are we going to be doing? Well, they're going to give you a mean and standard deviation. And in 7.2, the mean is always going to be 0, and the standard deviation is always going to be 1. In 7.3, it's not going to be that way. Okay? So we got to crawl before we can walk. And that's what they're showing you, basically 0, 1, 2, 0, negative 1, negative 2. And they're showing you how to draw the curve. Okay? There, 1.33. That's the standard deviation. Oh, they gave us, did they give us this? Okay. Here's the mean and standard deviation. So you plug and chug. 120 minus 100 over 15. Now look and see where all that comes from. Mu is 100. Sigma is 15. Well then, what is 120? 120 is the X. That's what they're asking. Yes, the observed value. And that's equal to 1.33. So now plot that on your handy dandy normal distribution. I don't want that yet. I don't want that yet. Okay, so draw it on your normal curve. Take the red line, and 1.33, that's 1.5 right there. So 1.33 would be right in here. Now they have given us a z-score basically. So that means that we're finding the what? Okay? If they give us the z-score, or give us enough to find the z-score, that means we got to find the area. If they give us the area, that means we got to find the what? Z-score. So that's why it pays to know what the 4-digit number is and what the 2-digit number is. Now in this case, they give us, we end up with a 2-digit number. So that means we have a z-score. We got to find the area. Now there's 2 ways to do it. One is to use the table. Everybody has a table in their book. It looks like this. That's called a z-table. There's a positive z and there's a negative z. Some books do them separately as 2 tables. Some books do them as 1 table. You need to find it in your book. Okay? Yeah, the one you haven't gotten. You got to go buy it when your check comes in. Okay?
Spend all my money on this thing.
Okay? So now you're looking at the z-score. Z is 1.33. So find 1.0. That's $1. And then add, or 1.3, $1.30. That's $1.33. So we got to add 3 cents. 0, 1, 2, 3. And that's the area up to 133. 91%. Okay? So let me go back. There. You need to write that down. Don't write down the whole thing. Maybe put you a box at 1.3 and go this way, and put you a box at 0.03 and then put 9.9082. Now there's a way you can do it on the calculator also. So use your handy dandy calculator. Then go to second bars. Second, VARS, and I think it's normal CDF. Negative infinity, comma, 1.33. Now a lot of people always ask me, why'd you plug in negative 9999? Well, you have infinity on your calculator? No, so you have to use 99999. I use 4 digits, you can use 10 digits, you can use 15 digits. You're going to get the same number. Huh? Yeah. Yeah, you can turn your calculator sideways and use number 8, but I wouldn't try it. Okay? So let's do it again. Second, bars, normal CDF, enter, negative 999,999, comma, 1.33. Now what if that's, hold on a second. That's that green area. See the green area right here? What if I want this area over here? Well, if you're using the table, you have to subtract it from 1. But if you're using your calculator, you go from 133 to 99999. So take a calculator, and if you want to find the right side, you say second bars, normal CDF, 1.33, comma, 99999. Because this is infinity. 0.09. Well, what's the complement of 91%? 9%. And that's how you find the z-scores. So let's do another one. That's right there. That's the complement. I just told you the complement. Finding the complement.
It's just the facts that I would try. You can subtract that together.
All right, you try this one. Find the area under the standard normal curve between negative 1.02 and z is equal to 2.94. What's the first thing you do? Draw a picture.
I can't draw them.
You're going to fail this test. But you might be able to, I don't know, go to Google and maybe.
Can I complain?
Yeah, just do that. No sense in work. Just complain. Tell them you want a trophy. Go downstairs and tell them you want a trophy. Draw a picture. Mean is equal to 0. Standard deviation is equal to 1. So that means 1, 2 on the right, negative 1, 2 on the left. Draw a line at negative 1.02 and 2.94, and then try to figure out how to find that area. In 7.2, the mean is always 0.
Yeah.
and the standard deviation is 1. And 7.3, it's not going to be that bad.
You tell you what, I can do it.
Draw a picture. Negative 1.02, I'll do it in red. Negative 1.02. Do the other in blue, 2.94. Now, they want to know what is the area between the red and the end of the blue, right? They said between, right?
Right.
So they want this area. That's the area they want. How do we get that green area? Well, let's say that you live in Anderson. You know it's 30 miles from Greenville to Anderson. And you travel to Spartanburg. The whole trip is 120 miles. Okay? I know it's not 120 miles to Spartanburg. I'm only using that for numbers, okay? I don't need no smart aleck, which is usually a male. It ain't 20 miles to Spartanburg. Shut up. All right. Sunday. The test is Sunday. All right, so how do I find out how far it is between the Greenville and Spartanburg? Addition. How about subtraction? Take the larger one and subtract the what? Smaller. So how are you going to find this one?
That same way.
Take the blue area and subtract the what?
Small.
The red area, and you get the green area. So do it. Find the green area, the blue area, and then find the red area. The blue area is at 2.94. And the red area is at negative 1.02. Now, if you have a calculator, you don't have to do it that way. You just go from negative 1.02 to 2.94. But if you have to use the table, you have to subtract. Okay? So, I'm going to find the blue. Well, they don't give you that. Sure, well, let's go back up here. Let's see. Back in 2.94. No, not going to be here, so I'm going to have to use a calculator. If you do go to use the table, you'll have to look up 2.9 and then 1, 0, 1, 2, 3, 4, the fifth column over. So it'll be 2.9 and then the fifth column over. If you use your handy dandy calculator, it's going to be second enter from negative 99999, comma 2.94. Enter. I got 0.9984. Write that down. 0.9984. Me too. Good job. So the blue is 0.9984. The area at 2.94 is equal to 0.9984. Now I got to find the red. So I hit second function. Hold on, trick of learning more. Second function, enter. Negative 9999 to negative what? 1.02. And in red is 0.1539. The area at negative 1.02 is equal to 0.1539. If you subtract those two, you're going to get 14 minus 9 is 5, 7 minus 3 is 4, 9 minus 5 is 4, 9 minus 1 is what? 8. So the green area is 84%, 84.5%. Yes, you can do. Take your handy dandy calculator and you can go second bars, normal CDF, negative 1.02, comma 2.94. .8445. Okay. Yep. Now let's do something else. That's that one. All right, this is 7.3. What happens when you don't have the mean is 0 and the standard deviation is 1? What do? You just don't do it. You just quit.
Draw a picture.
Yep, draw a picture. That's the first thing you do.
Whatever traffic.
Draw a picture and add your mean and standard deviations on it. Now these are going to be more complicated, so you better take good notes on these.
You should record those videos.
Yeah, we put them on YouTube.
You find mine. And most I can probably like it better. You just don't have that.
What is the score of a student whose percentile is at the 85th percentile? So area is equal to 0.8500 because you got an area. Yeah, but you don't know which one to put it in. Actually, unless you just came out of probability and statistics, you probably don't know how to do it. All right, so 1049, and of course they have to use bad numbers to add. So if somebody give me the two numbers over here, I'm not doing it in my head. 1230, and what else? 1427, and on this side, 8 what? 860, and 671. Now, let's talk about 85%. Let's use our empirical rule. We know this is 50%, right? Well, what's 50 plus 34? 84%. So I bet you $1 if I put a line right on the right side of this line right here, I bet that'll be somewhere around 85%, right? I'm going to put 0.8500. So it looks like to me they've given us an area and we got to find the what? Z-scores. So we need this Z-score right here. It gives us 85%. So we go to our handy dandy, well, not calculator yet, but we're going to the handy dandy table. And we'll have to go to the table first. Okay. They've already done, they didn't use the table. Okay. We don't have the table, so we're going to use a calculator. Where's my problem? There it is. Okay, on your calculator, look for the inverse bar, second bars, and then pull up inverse norm. Second bars is number 3. See it?
Correct.
And what's the percentage? What's the area?
0.8500.
Type that in. 0.8500, parentheses, and enter. So your Z-score is 1.04. So that Z-score is 1.04. Well, it didn't ask for a Z-score. What did it ask for? What is the what?
Score
Of the student. So they want X. $189 times 1.04. Somebody calculate that out for me. Plus 1049. Somebody, what's 189 times what? 1.04. That would be 189 would be 7.3 something. So 189 would be 196.3. Huh? What's 189 times 1.04?
194.
I thought that's what I said. 193 point what?
196.56.
Okay, I said 0.3. Plus 1049. Now let me ask you a question. What number you know it's over? 1230. But you know it's not over by far. So if you get something like 1500, you know yourself is wrong. Okay? You gotta use a little bit of common sense. So 200 plus, that's gonna be what? 1249?
25.
Okay, yeah, whatever. X is equal to 1240 what? Point six? 56. So, the 85th percentile is chopped off at 1246. Anything above 1246, you're in the top 15%. Anything below 1246, you're in the bottom 85%. So you done got mad at me. I don't blame you. I'd leave too. Okay?
No, now tell me that again. You took the 189 your standard deviation. Okay, because it's
Oz plus mu. Oz, the O is omega, which is, sigma, which is your standard deviation. The Z is 1.04, and the mean is 1049.
tell me why this doesn't work. It doesn't, I just proved it. But you can tell me why you always get it. Why am I thinking that?
What?
I was thinking if 1049, that's 50%, right?
Yeah.
So double that would be 100%, correct?
Yeah.
So why couldn't you take that, which you doubled, times 80.85? It doesn't work. That should work, shouldn't it?
No. No.
No.
Because if you double 1049, you get 2,000.
Yeah.
The numbers
You
are
see what I'm
not right.
saying?
Yeah, but you can't do that.
Why don't that work?
Then I was doing it more after I thought.
Come on, man.
Because you gotta.
Because you're trying to find that spot right here. You're trying to find that spot. Now you can use your empirical rule and say, okay, this is 34 right here, but the 34 and that gives you 84. So you can say, okay, well, I've got to divide this up into, let's see, 84. I got to get this into 1% increments. And you say, okay, that's 13.5. 13.5%, but what's the difference between here and here? Good gosh, it's what? 189. So you got to get each one of these in 189 little slithers. And then you go, okay, well, 189 slithers. Let's do that. Let's take 189 slithers. Let's take the percentage, which is 0.135, which is 13.5, right? So you take 0.135, 0.135 divided by 189 slithers, and that gives you 0.0007, and you need to divide that into 1. No, yeah, because you're trying to get one more. So you're going to have to divide that by 1 so you can get how many of those slithers make up 1 to make that 84 into 85.
I was in left field, you just jumped over the back and ran off the start.
Well, I'm just telling you. Let's see if I would divide that. Yeah, that would be it. So now I got to take.
You see what I'm thinking? I don't know why I don't know that.
I'm still trying to do it. Yeah, it don't work.
I mean, it's like a little way to do it, though.
1 divided by 0.0.
Yeah, see that. I'll take 85%.
Yeah, it don't work. But that's how you would do it. Okay? And don't worry, we're going to go over more, so, because it's going to make up probably 50% of your test, with the rest of the test being from 7.2 and 6.1 and 6.2. 7.1 is not going to make up a lot of the test. Next. Time to go. If we did this, is this the answer? All right, try that. It is known that the length of a certain steel rod is normally distributed with a mean of 100 and a standard deviation of 0.45. So that's 0.45 centimeters is not very big. Suppose that manufacturer wants to accept 90% of all rods manufactured. Determine the length of rods that make the middle 90% of all rods manufactured. You got to draw a picture on this one. Or you could just quit.
Still won't get one that don't work.
Well, you worry about that until the end of the semester and see what that gets you. I'll help you draw a picture.
I'm just gonna try my method again, maybe it'll work on this.
Yeah. You keep doing that.
You know, let's say it's like that's John.
100, this is 100.45, and this is 100.90, and this is 100, this is 99.55, 99.55, and 99.10. Now, what is this little area right here? That's 2.5, right?
Correct.
And that's 2.5 right there. So this is 13.5, but they want to know the top 90%, the middle 90%. So you got to multiply this times 2, which would be right in there, and then this times 2, because that's 2.5. And that's 2.5, and that's 2.5, and that's 2.5. So what are you taking out? The top what? Top 5% and the what? And how much is left in the middle?
90.
It's a miracle. And that leaves 90% in the middle.
I think that's not really. I don't know, bothers me that we're not really getting the exact numbers.
You are. In fact, the Z-score is more detailed than the empirical rule.
Like, I feel like we're just guesstimating on where we are.
No, you are guesstimating where the lines are, but the empirical rule is going to tell you exactly where the line. I mean, not the empirical rule. The Z-score is going to tell you exactly where the line is. So, let's focus on this guy. Let's focus on getting this Z-score right here, because these are symmetric. Once you do this one, you know what that means. So this is 5%. 5% is, let's see, 0.05. So I need an area of 0.0500. So somebody needs to do inverse norm of 0.500. Let's see, common sense looks like it's going to be around negative 1.8 or 1.9, something like that. What do you come up with? Okay, is that what everybody came out with? Negative 1.64.
Oh, 90.
Inverse norm, 0.0500, close parentheses. What'd you get? Okay. So now you can figure out this right here is positive 1.64 because it's symmetrical. This is the same as this. So now you just got to figure from the area from negative 1.64 to what? Positive 1.64. So find your area. No, not your area. Hold on. No. You got your area, 90%. You got to find the scores. I'm sorry. So the lower z-score, the z-score on your lower side is equal to negative, or what's the standard deviation? 0.45 Oz, negative 1.64 plus 100. Half of 164 is what? 82? So it's maybe 80, negative 80 plus 100 is 20.
Yep, negative 0.73 plus 100. Which is 99.26.
Is that a z-score or the x?
I'm finding the x.
Okay. So the z-score was the negative 1.6.
Yeah. What does it come out to be?
I got 99.262.
Okay, let's look and see if that's right. What's above 99.1? 99.2. So that's about right. So what'd you come out with?
99.262.
99.262. All right, now let's do the upper score. Z, so upper score is equal to 0.45 times 1.64 plus 100. What do you get on that side? 100.738. And that's how you do z-scores.
So it was actually for the lower and upper, and not the middle.
Now it says, where are the cutoff scores for the middle 90%?
Okay.
So any rod between 99.3 centimeters and 100.7 centimeters is in the top 90%, is in the 90%, middle 90%. Capiche?
Don't take it easy. You know, you get used to it.
Well, that's why we're going to work on homework Monday, Tuesday. Yeah, doing problems at home.
I'm talking about this, not that.
All right, who's got questions? I'm going to throw this back up here. Does anybody have any questions pertaining to this? No questions at all?
Try to keep it back that way. That's it. Figure out what I'm doing.
All right. Well, if y'all don't have any questions, I'll see y'all Monday and Tuesday, whatever time y'all back.
Some good stuff. But too bad not for